timer.
Alex?
Hey, good morning.
Morning. Is it still morning?
Yes, sir. 11:05.
Don't forget, y'all have lab today. Most of the time, I already gave you the answers. Y'all gonna have, time to look at the models. I recommend y'all do the bonus. It should already be open and available to y'all, but you gotta go to the Science Learning Center, okay?
Yes, sir.
To get the code word. Diego, make sure you do that. Because next week's not just our lecture exam.
It's practical.
Yeah, come Wednesday next week for your practical. It's gonna cover worksheets, chapter
12.
Worksheet number 12 through 14?
Yeah.
Let's see here.
I don't think so.
That's what they said, that's not here today.
Well, he's getting late.
Celeste? Question?
The exam is 8 and 9, right? Like
Just 8 and 9. Bring a Scantron. If I have your blue book, I'll bring it the day of. If you want it after class, just follow me, I'll give it to you if I have it.
The essay questions differentiate the three muscle types, right?
Yeah, I'm gonna go over all that with you today real quick. Look, some of the things you want to recognize, of course, this is more for lab, but I do want you to recognize a connective tissue, like rope-like, if it connects muscle to bone, that's a tendon, right?
Yes.
Whereas if you have a connected bone to bone, that connective tissue would be called a what? A ligament. Okay, so be able to distinguish tendon from ligament. Recognize tendon and ligaments are poorly vascular. So if you got a slight tear, it can heal, just take a while. But if you were to rupture, which means to tear it, that's not likely going to heal. Okay? Now, a lot of these terms had sarco within them, right? Or myo. I need you to recognize sarcolemma is the fancy name for the cell membrane of the muscle cell, right? Well then what was sarcomere? Sarcomere is the functional unit, the smallest component does its job, which is to contract. And that is, and you need to know, it's from one we say Z-disc to another Z-disc. So sarcolemma, cell membrane, sarcomere, functional unit, right? You want to recognize skeletal muscle striated. I'm trying to figure out who is that. It's striated. What causes the striations? Why do you see these dark regions and light regions? What did we say? The arrangement of
Protein. Or
the myosin and
actin.
okay, we call those myofilaments. So the way they're arranged gives us the striations, okay? So you need to recognize that they overlap. It's gonna look darker, and you need to know the letter was the A band. Just think of dark has A within it. And where you only see the actin in blue, it's thinner, it's gonna look lighter. That's your I band. Light has I in it. To help you remember, the light band has the I. Okay? Y'all okay with that? We need to recognize that neurons, your nervous system needs to maintain homeostasis, right? You need to communicate to targets. What are targets that you can communicate to? Just 3 things.
Glands, muscles,
Glands, muscles,
and other neurons.
and other neurons. So you can communicate to sweat glands, oil glands, glands that make hormones. You can communicate to other neurons and skeletal, cardiac, or smooth muscle. Okay? Now, when you communicate to these targets, if you're trying to excite them, you're first going to be what? How does the neuron communicate? By releasing chemicals in general. What were the general chemicals called? What's the NT stand for on the board?
Oh,
They're called
transmitters?
neuro. Transmitters, and there's different types. Obviously, we need to know the type that was used to communicate to skeletal muscle. It's called acetylcholine. I'm not gonna put ACH, it's gonna be named out, spelled out acetylcholine. And they're gonna be stored inside the neuron in little vesicles. What were the little vesicles called? They're called synaptic vesicles. Okay. What is going on for a neuron to communicate to a target? We're trying to change the voltage inside. What was the resting voltage called when you compare the inside to outside? It's called the resting what? I didn't put it in. What's it called? When at rest, most cells, resting membrane potential is at minus 70 millivolts. Remember, we said the inside is more negative compared to the outside. And when a cell's at rest, that's called the cell's resting memory potential. Okay? So first of all, we need to know what an action potential is. What's an action potential? And they erased it. What is an action potential? Now, I can just wait till lab and continue on.
It's
So
when
I
the
got all
muscle.
the time I need
It's when the muscle.
for a review.
The muscle contracting.
No. That's what will occur if it happens in a muscle. But if I create an action potential in a gland, what would the gland be doing?
Releasing.
Releasing what? Whatever it makes.
Yeah.
Whereas if I create an action potential in a neuron, it's going to be caused to release
Transmitters.
neurotransmitters. So we need to know generic definition for action potential, not exactly what would happen in these three different targets. What is an action potential? Celeste?
When something happens.
When something happens ain't good enough. Come on, I've written this down before. Now's the time to just say what you think. It's not gonna be counted wrong. Is it forever?
No.
No, it's brief. What's going on? Brief what? Reversal of what?
Of an action.
A brief release.
Well, first of all, let's go here. You create an action potential in the muscle's going to contract. You create an action potential in a neuron, the neuron's going to release
Neurotransmitter.
And if it were a gland, the gland's gonna release its whatever it makes. All right, I'm still waiting.
The target / cells.
What's that graph showing? What did we change? I drew a little, looks like a mountain. What are you changing?
Polarization.
You're changing what?
Polarization.
So you're changing the voltage,
Voltage.
Yes.
Yeah.
which is the cell's what? Resting memory potential from what to what?
High to low. Low to high.
Give me the voltage.
Negative 70 goes up to positive 30, back down to.
Here you go. There it is. There's the action potential. It's a brief, not forever reversal of the inside voltage from minus 70 to 30 millivolts. If you create that in the muscle, you need to know that the muscle will contract. Whereas if you create that in the gland's not going to contract. It's going to release whatever it makes. And if you have an action potential occurring in a neuron, the neuron's not going to contract. It's going to be caused to release neurotransmitters. Now, the first type of channels that open up are the ones that bind to the neurotransmitter. How do you refer to this name? How do you name that channel? This one, that bounded to the acetylcholine.
Voltage gate.
No, voltage didn't open it up. What opened it up? The chemical, the neurotransmitter. So this is a chemical gated channel for ions to flow in and out. What do you call positive ions in general?
Cation.
Cations. So the channels that open up in response to the chemicals are properly named chemically gated channels. Does that create your action potential though?
No.
No, not necessarily. How do you create an action potential then? You have to open up which channels?
Voltage.
Voltage for which ion?
Uh,
Sodium. So
Sodium.
this is a voltage gate channel, indicating to me it's not gonna open unless I change the voltage to a different state. And we have to reach a certain level of change, and that level of change is called the threshold. Either you reach it or you don't, and our threshold to cause these channels to open is about minus 50 millivolts. Okay, so which channels create an action potential? Technically, which ones?
voltage.
Voltage, because that just because you open up chemical doesn't necessarily mean you're gonna reach that level of voltage change. But if you open up one, what happens if there's one next to it?
They all open up.
They all open, so they're not drawn here, but this little pink line indicates the voltage gate channel's opening, whereas one opens, the one next to that will open, next to that one will open. And I don't know if it says in the book, I believe it relates it to like dominoes falling, where if one domino falls, they'll all fall. But in this case, all channels are opening. And then the voltage gate channels open along the T-tubule, and that causes the release of calcium. And we need calcium for a muscle to contract. So about 30 millivolts, calcium's being released, the muscle is contracting, okay? First of all, what is an action potential? A brief reversal of the inside cell's resting memory potential from minus 70 millivolts to positive 30 millivolts. If I create that in a neuron, what would the neuron do?
Release neurotransmitters.
Release neurotransmitters. Whereas if I create it in the muscle will eventually what? Contract. If it's a gland happening in the gland's gonna release what it makes. Okay. Which type of channels create an action potential?
Voltage.
Voltage for sodium. As positive ions come in, let's say you open up the chemically gated channel, positive ions come in. You need to know the term, anything above minus 70 millivolts as positive ions come in is called depolarization. Now, why did sodium come in? More sodium comes in than potassium leaves. So that means, what's causing sodium to come in the cell? Diffusion. Things naturally want to go from what?
Low to
High to low. So there's more sodium outside, you open a channel, it wants to come in. There's more potassium inside, so there's a channel that wants to go out. So in the beginning, you have both ions flowing, one in, one out, but which one more comes in? Sodium. So the inside's becoming depolarized. Okay? Have I reached threshold yet? No, when I get to what? Negative 50. But once I reach threshold, all voltage gated channels open and you go to 30 millivolts, causing the release of calcium. Okay, so how's calcium used for muscle to contract?
It allows the cross bridge. It moves the tropin.
What is a cross bridge? That's that bridge I need to cross to graduate? What?
Cross bridge is the myosin connecting to the actin.
Yes, when myosin binds to actin, they refer to that as a cross bridge. At first, myosin cannot bind to actin. If you look up here, the binding sites are covered up by a protein called tropomyosin. Okay. So I need calcium basically to open the binding sites, to expose them. How did it do that? Well, it bound to troponin, and when it bounds to troponin here, it turns and shifts tropomyosin away from the binding sites. Now, if you want to keep it simple, you could say calcium's needed to expose binding sites on actin. But technically, it bound first to a protein called troponin, pushed tropomyosin to the side, and now the binding sites are exposed. Okay? Then you also, after that, you need what? ATP. ATP provides energy to do what's called a power stroke, so that you can move actin on both sides of the sarcomere to the middle, right? And get enough sarcomeres in the whole muscle will eventually contract, getting shorter in length. You okay with it? So what's an action potential you need to know? What channels create the action potential? Voltage for sodium. What's a threshold mean? What's a threshold referring to? Reaching a certain change in voltage to open up voltage gated channels. Okay, now after you release calcium, the muscle contracts, you're at 30 millivolts, right? How do you come back to rest? How's the inside gonna go back to minus 70? At 30 millivolts, what causes coming back to rest? The term for coming back to rest is called repolarization, but how does that happen? What's it? The clown from the movie, right? It's Halloween. What?
No, the enzymes.
The gates open up and
Look, at 30 millivolts, all sodium channels are closed. I understand that,
yes.
right? One closes because here you have a neurotransmitter breaking down acetylcholine, and over here, these only open for a brief period of time, the voltage for sodium. But what causes us to come back toward rest?
Then we open voltage gates again. Or would it be chemical gates?
Remember, you're at 30 millivolts. How are we gonna get down to minus 70 now?
You need a negative ion.
No.
You need to really.
Picture's here. It's right here. What's going on? You're at 30 millivolts now.
Potassium.
Voltage gated channels here are now what? At 30. Is it still open?
No.
No, it's closed. So the muscle's done contracting. I want to come back to rest.
So potassium enters back into
Enters back.
It leaves
or
Okay, so what's causing it to leave?
a voltage gate
A voltage gated channel for potassium opens when?
when it's at 30.
At 30 millivolts, after the muscle's contracted and all sodium channels are closed, this is a voltage gated channel for potassium. When you're at 30 millivolts, that causes it to open. That's why it's called voltage. It only opens up at a certain voltage. And there's more potassium where?
Inside.
Inside, like here. So it wants to go
Outside.
out. So as it goes out, you're coming back to rest. And the term for coming back to rest is called
Repolarization.
repolarization. Now, yes, you're open a little too long, you'll fall below rest. Anything below minus 70 is called
Hypo.
hyperpolarization. Finally, the channel's closed, and which you haven't experienced yet, I don't know when I'll get to it. You have what's called leaky channels that are just naturally always open, bringing you back to minus 70 millivolts. So you need to know what is the general definition, what an action potential is. You need to know that voltage gated channels for sodium created by reaching a certain threshold. You know what a threshold, and you know what that is. You need to know that the term for anything above minus 70 millivolts is called depolarization. After the muscle, in this case, contracts, anytime coming back to rest, it's called repolarization. You want to recognize voltage gated channels for potassium cause repolarization. Yes, they also cause hyperpolarization here, but mainly you want to recognize they cause the repolarization, coming back to rest. Okay? Okay, what causes rigor mortis? That stiffening state when you pass on where it looks like the body's all stiff.
Your body stops making ATP.
Yes, one reason is because you're no longer making ATP. Okay, well, what's ATP doing here?
Breaking the cross bridge.
Yes, if you're no longer making ATP, any previous cross bridges that are attached to actin, they're not going to come off. Only due to time will they come off. So technically, your rigor mortis occurs because you're no longer making ATP to disattach cross bridges. Okay, that's the main thing. The other thing is when cells die, organelles will release their contents. So here, calcium is stored in the sarcoplasmic reticulum. Therefore, when the cell dies, you have a lot more calcium release. And if there's more calcium release, you'll form more
Cross bridges.
cross bridges. And if there's no ATP, it's not going to come up. So please know what causes rigor mortis. What causes rigor mortis? If you want to go the easy route, no more ATP is produced to disattach cross bridges. All right, motor units. Motor units are muscle cells and one neuron, the neuron that communicates to the muscle cells. You can have small motor units and large motor units. Small motor units only communicate to a few muscle cells, let's say. Large motor units, many. Which ones do your nervous system call and play first?
Small.
Small motor units. Then if you need more tension, more force, you incorporate mid-size and then the large. What's the advantage of small?
Fine.
More fine
motions.
control, whereas large give you more tension, more force. So I need you to recognize two ways you get a stronger force, tension. If you want more tension out of the whole muscle, not the cell, the whole muscle, would you want to communicate to small or large motor units? Large. But by the time you get to the large, you're already also communicating to what? All the others, the small and the mid-size. So in order to get more tension out of the muscle, you incorporate multiple, all motor units from small to large. What's another way you'll get more tension but out of the cell? How do you get more tension, not from the whole muscle, but a particular cell? Let's look at this, look. Remember we have the whole muscle here? And you broke it down into units, right? So you had motor units, that would be the neurons communicating to the muscle cells, right? But how do I get a stronger tension just out of one cell? What's this indicating?
I did a
The amount of-
continuous stimuli.
Stimuli, what's stimuli?
Any,
Neurotransmitter?
it's just
In
anything
this
that-
case, stimuli is a generic term, but in this case, it's representing the release of what? Neurotransmitters. Didn't we see this on the board?
Yes.
Each little arrow indicates how many times the neuron released
Transmitters.
neurotransmitters. If I release neurotransmitters within a shorter period of time, I have more what? Neurotransmitters.
Oh.
And so what's going on in this picture here, look. This indicates you release neurotransmitters one time, the muscle contracts. You think you threw out all the calcium right away from the sarco?
Reticulum.
Do you think because one action potential occurs, you get to throw out all the calcium in the first shot?
No.
No, you can release some. So going back to this picture, if I allow the muscle to come back to rest, all the calcium's going back into the sarcoplasmic reticulum. But what happens if I don't allow it time to put it all back in?
Then it all comes out.
And then I tell it to release again. You'll release even more. Then again, I communicate, release more, until finally what? All the calcium has been released and you got the maximum tension out of the muscle cell. I gave a scenario in my other class, all right? Let me pick on, I guess. You want to pick on you, Pearl? All right, let's say Pearl has got some change in her pocket. I want the change, right? And I shook her a little bit and some of the change fell. Not all of it, but some of it. But then I'd shake her again. Wait, before I shake her again, she picks up the change and puts it back in the pocket, okay? But if I shake her and it comes out and she's trying to pick it up and then I kick her, right? Even more change comes out before she can pick it up, right? And if I keep doing it, she won't be able to pick it all up. Eventually I'll get all the change out of her pocket. So that's what's going on, is that the nerve cells releasing neurotransmitter and each time causing the release of calcium and not allowing time in between for the calcium to be put back until eventually all the calcium is released and you get the maximum tension out of the muscle because you're forming more cross bridges. Okay? Did that help? I'm sorry, Pearl.
It's fine.
But y'all got the idea, right?
Yes.
So you're going to be asked 2 ways you get a stronger tension out of the muscle. If I'm at the cell level, I would increase the frequency of neurotransmitter release, increase the communication to the muscle cell, where I'll get all calcium release. 2, I would communicate to all the motor units from small to large. And what's a motor unit? A motor unit is a neuron and the number of muscle cells that it communicates to. Okay? We need to know the difference between isotonic and isometric contraction. When the muscle contracts and it overcomes the load, it gets shorter in length. That's called isotonic. If If a muscle contracts, does not overcome the load, but tension's being produced, yet the length stays the same, that's called isometric. So let's give an example. Y'all all picked up weights before, right? Is this yours, John?
No. You did it.
I'm sorry, I forgot Timmy's sick.
No, I'm not. I'm over it.
You're good?
You're over it? Yeah.
Well, just be safe.
Yeah.
Let's just say this is a weight, right? Everybody's probably experienced weights. Biceps do flexion, right? So if I pick it up, I'm overcoming the load, my biceps getting shorter. What type of contraction would that be? Isotonic, I know the movement's flexion, good. But is that isotonic or isometric?
Isotonic.
Isotonic, I'm overcoming the load and I can feel my muscle getting shorter in length. Now, here's something heavy, crap. I'm producing tension, I'm trying to pick it up, but I'm not enough to overcome the load. And the length stays the what? Same. That's called isometric. Okay, so I'll have one of them in the exam. You tell me if it's isotonic or isometric. Now, you want to recognize when cells make ATP, the process is called cellular
Respiration.
I know you can also use creatine phosphate, but we're going to just focus on aerobic and anaerobic pathway, okay? Which one, aerobic or anaerobic, will make more ATP?
Aerobic.
Aerobic, so that should sustain a long-term event, right? Contraction, like marathon. We want to know what can you use to make ATP? What do you need to deliver to the cell?
For which one?
To make it, either one.
Either
You
one,
need to deliver what?
Glucose.
Which is a nutrient,
Nutrients.
and
Then oxygen.
oxygen if
depending on
you're going to
which
make a
one.
lot of ATP, right?
Yes.
Okay. So we want to recognize that what is glycolysis? So that's when you're using glucose and converting it into molecules called fruitic acid. Glycolysis, glyco means sugar, glucose, sugar. Lysis means to break. So you're chopping this in half and making 2 molecules of fruitic acid. Okay? You want to recognize that that doesn't make a lot of ATP. So that's only going to sustain a very short, brief period contraction. So here's the question. Does glycolysis happen in both pathways or one? What's yes? I didn't. Did it happen in both?
Yes.
Okay, so it happens in both. They just didn't label it here, right?
Yeah.
Which pathway is just totally dependent, stops at glycolysis?
Anaerobic.
Anaerobic, okay. So tell me, if you don't get oxygen at this point, what is the waste product that builds up if you accumulate pyruvic acid and you can't get it to go to the mitochondria? You need to recognize the waste product is called lactic acid, which eventually you don't get enough oxygen to the cell. Pyruvic acid will turn into lactic acid. And that's when you get that burning sensation if you ever did weights. The muscle's tired, you have to allow it to recuperate. Get rid of the lactic acid, okay? So, first of all, the term for making ATP is called cellular respiration. Aerobic makes more ATP. Glycolysis happens in both pathways, which only makes a little ATP. Glycolysis only stops at the anaerobic, right? At this point here, let's say you get enough oxygen, pyruvic acid in the aerobic pathway will enter the mitochondria and you make a lot of ATP. So you can sustain an event for hours. Also recognize you also made a little bit of water and carbon dioxide, okay? Okay, so, Alan, process to make ATP is called cellular respiration. Aerobic makes more ATP. Anaerobic stops at glycolysis, even though glycolysis happens in both pathways. Which pathway made a little bit of water?
Aerobic.
Aerobic. And which pathway made carbon dioxide?
Aerobic.
Aerobic. Right. Can you use different nutrients to make ATP?
Yes.
Fatty acid came from a lipid.
And amino acid.
Amino acid came from protein. I like to just think of an assembly line where glucose starts at the front, and at the end is ATP. Fatty acids and fatty acids and amino acids, they can jump further along the assembly line and still end up with making ATP, okay? Now, I do need you to recognize that what is glycogen?
Oh, it's whenever you have a buildup of glucose that it turns into glycogen.
Okay, so if you got extra glucose, your body doesn't like to get rid of an energy source. So let's say glucose is like a box to a train, and we'll start hooking them up like a train, and we'll store it in our muscle for a reserve of fuel. You also could store it in your liver. So glycogen is the storage form of what? Glucose, which you can store a little bit in your muscle and the liver. What would happen if you have extra glucose after that? You'll convert it to lipid, fat. You store it that way. Any nutrient, even if you have extra proteins, it can be eventually stored lipids. Okay? Now you're fasting, you're on Survivor, trying to look for food. What's the first thing you're going to use for energy?
The glucose.
Not the fat, Alec.
The glucose that you.
The glycogen.
The glycogen.
We'll chop it up and deliver it to tissues as glucose. So the first thing you use for energy is glycogen. If you used all that, then Alex, you'll use your fat. Then after you use all your fat, what do you think you'll use next?
Your protein.
Your skeletal muscle. You'll see survivors of Holocaust or people, just fast. You'll see their frame get smaller because they're losing muscle. Okay? So what am I getting at here? You need to recognize glycogen as the storage form of glucose. Right. You need to recognize glycolysis. You're converting glucose into pyruvic acid. Makes a lot or a little ATP? A little. All right. All right, when we look at smooth muscle, it's using calcium differently here. Calcium in skeletal was to expose binding sites, right, on actin. How is the calcium used in a smooth muscle, though? It's activating a protein called calmodulin. You know it activates calmodulin. Well, what does it do? Okay, well, calmodulin eventually help enzymes to shuttle phosphates from ATP to glycine. But the key thing is it activates calmodulin. Okay? All right. Myoglobin is a protein similar to hemoglobin in that it will hold a reserve of what? Oxygen, and you find that in muscle cells. Okay. Your essay, compare and contrast the 3 muscle types. Give me 14 so you can compare and contrast. And it's easy.
Number of nucleus.
Okay, let's start with location.
Oh, okay.
Okay. Where are skeletal muscles located?
Attached to the bottom.
Okay. In the bone?
No.
No, attached. I don't want to see in the bone. I'm gonna count that wrong. They're not in your bones, they're attached to your bone. Skeletal. How about cardiac muscle? Where do we find cardiac muscle?
In the heart.
Within the walls of the heart. How about smooth muscle? Most often we'll find it within walls of organs doing what? Let's keep it general. Not just digestion, but you're pushing a solid or a liquid through the organ. So that would include like digestive organs, urinary organs, or blood vessels. Notice how they kept it general? So within the walls of organs, most often where you're pushing a solid or a liquid. Okay? Now there'd be other areas, right? Like your smooth muscle of the skin that raises your hair follicles. Remember that one? Erector pili. Or like in the iris, the eye controls the diameter of the pupil. But most often within walls of organs, pushing a solid or a liquid. So we did location and we did, well, that's all we did, right? Location. Let's do function. What's skeletal muscle for?
Voluntary movement.
Voluntary movement. Anything else? Communication. Produce heat times you're cold, right? It'll contract quickly. You can just get away with just saying voluntary movement for one. But cardiac muscle, what's the function of cardiac muscle?
Pumps blood.
Pumps blood. So you're pushing blood. And most often smooth muscle, you're pushing what?
Liquid.
A solid or a liquid through an organ. So I don't know, Perla, you want to help us out and write out? Well, I'll do it. So some of the things we can compare for the muscle, we said location was one. function, right? How about number of nuclei? Which one has many nuclei per cell?
Skeletal.
Skeletal. Which one has 1 to 2 nuclei per cell?
Cardiac.
Cardiac. Which one only has specifically 1 nuclei per cell? Smooth. How about striations, whether you have them or not? Which ones are striated where you see dark regions and light regions?
Skeletal.
Skeletal and cardiac.
Cardiac.
Smooth muscle, you won't see the striations. Which one's the only one you can voluntarily control?
Skeletal.
Skeletal. Which one has pacemaker cells where if you took out of the body, it may still contract?
Cardiac.
Cardiac and areas of digestion, smooth.
Okay.
Which one can contract due to stretching it and activate reflexes? Smooth and cardiac.
All would it
Which one's communicated not just by neurotransmitters but by hormones?
smooth?
Fight or flight, adrenaline. Cardiac would cause heart rate to go up, and areas of digestion you can make hormones to promote or inhibit digestion. These are more, detailed. You want to keep it easy. You need to pick 4. Focus on those. Okay? Location, function, number of nuclei, striations or not, and which one's voluntary. Let me see the review. I forgot to mention, when you work out muscles, they can get larger, right? You're adding protein to what you damaged. You're adding more myosin and actin. And when a muscle gets larger, that's called hypertrophy. So on the review, what's hypertrophy? Muscles getting larger by adding protein. What happens if you don't use something?
You lose it.
You lose it. So you ever seen someone with a spinal cord injury? Let's say they can't communicate to the muscles of the legs. Do they get larger or smaller? They degenerate, they get smaller. The term is called atrophy. I don't have atrophy here, but hypertrophy means get larger by adding protein, okay? Which vessels will deliver oxygen nutrients to your muscle? What were they called?
Capillaries.
Capillaries. What is glycogen? The storage form of
Glucose.
glucose. Which contraction does the muscle get shorter in length? Isotonic or isometric?
Tonic.
Isotonic. What causes rigor mortis? You're no longer making
ATP.
ATP. What do we call when myosin binds to actin? You formed a cross bridge. Channels that open up in response to chemicals are
Chemically
chemically gated, or you say ligand.
ligand.
Channels that open up in response to voltage changes are referred to as
Voltage gated.
voltage gated. What happens when you reach about threshold, about minus 50 millivolts? Voltage gated channels for sodium open, creating our action potential. I didn't say in a muscle. It could have been a
No.
gland. We just say you create an action potential, okay? What is the process of glycolysis? What are you converting to what? No? You're converting glucose into
Fruvic acid.
fruvic acid. Does that make a lot of ATP?
No.
No. What is the minimum voltage called to create an action potential?
Threshold.
The threshold. What's muscle tone?
Oh, that they're in a constant state of tension.
Your muscles are always in a slight state of contraction. They're never totally flaccid limb. Unless you had like a stroke where you lose communication to the muscle and it goes totally flaccid. They should always be in a slight state of contraction called muscle tone. Okay? What is the sarcomere? Oh, that's that villain from Flash Gordon movie.
A functional unit.
No, that was me. Anyway, go ahead.
Functional unit
The
of
functional unit
the
of
fiber, the muscle fiber.
Alright. It's the functional unit of the muscles, right?
Yeah.
Skeletal muscle. Whatever you want to get down to, muscle cells fine. Do you make ATP in anaerobic cellular respiration? Yes or no?
Solar respiration. What?
You make ATP in the anaerobic pathway.
Yes.
Yeah?
Yes.
Just not a lot, right?
Yeah.
Okay. Does glycolysis happen in both pathways?
Yes.
Yes. Does it happen in the cytosol? Glycolysis?
Yes.
Yes, somewhere in here I thought it said in the cytosol.
Yeah, glycolysis and cytosol.
Oh, duh. Okay. when it comes to neurotransmitters, they're stored in little vesicles called
Starts with an S.
synaptic.
Synaptic.
Synaptic, when you get a synapse, it means a point of communication. So like even the space here between the neuron and the muscle is called a cleft, synaptic cleft. Now, what's a neuromuscular junction though?
It's where they communicate?
It's the point of communication between the whole neuron and the muscle. All of this together, this region, is known as the neuromuscular junction. What waste product do you make during aerobic cellular respiration?
Lactic. No. No. Carbon dioxide and water?
Yeah, the carbon dioxide. We already said compare the 3 muscle types, right? Keep it easy, that's your essay. How are muscles communicated to? By release of neurotransmitters, most often. But like the heart can be communicated like by adrenaline, right? Which is a hormone. But most often neurotransmitters. These here, which one has pacemaker cells? That's if you're gonna use that for the essay, okay? What type of ions flow in causing depolarization? Cation. What type of ions flow out causing repolarization?
Cations.
They're still cations. It's just one flows in, one flows out. Why is they flowing in here?
Because they want to go for
Because
low to
there's
high.
more what? Sodium outside? Why is this one flowing out? Because there's more potassium
outside.
inside, wants to go out. So, which ions flow in the cell causing depolarization?
Sodium.
Sodium. And which ions will flow out to cause repolarization?
Potassium.
Potassium. Alright. I think I answered everything on the chapter 9. Let me just make sure. I know, we'll go over chapter 8 in a little bit. What time is it? We still got time. Yeah, I'll look at this in the lab. Let's just do chapter 9 real quick. I know exactly what you need.
What was that?
What was what?
What are we going to look at in the lab?
Oh, I'll go over the exam, make sure I covered everything.
Oh, okay, okay.
But I just want to go real quick what I know of that you for sure need to know. We need to know the way you can name joints are 2 different ways. One is by
Movement?
structure. We're not going to say movement.
Function.
First,
sorry.
we're going to say structure, which means what type of tissue is in between the 2 bones, and by function, which means movement. So on the exam, I'm not going to say tissue and movement. I'm going to say structure and
Function. No.
function.
Yeah.
Oh, that's chapter 9. So, 2 ways you're able to name a joint. One's by structure, the other one's by function. If I say structure, they're referring to the tissue. The 3 choices of structure could be a fibrous joint, cartilaginous joint, or a synovial joint. If they mean movement, they're referring, or function. They're gonna say function, but they mean movement. Your choices are no movement, which is synarthrosis, slight movement, which is amphiarthrosis, and free movement, which is diarthrosis. If you need help, think of SAD. Each letter represents the S, A, D, SAD. So from S, no movement, A, slight movement, D, free movement. Okay? Now, what were the types of fibrous joints? So let's say I say this is a suture. Tell me by structure what type joint that would be.
Fibrous.
Fibrous. If I say it's a syndesmosis, which means short ligament, what type of joint by structure is that?
Fibrous.
Fibrous. Or if I say it's the teeth embedded into your mandible called gomphosis. Gomphosis was an example of a fibrous joint. What were the example cartilaginous joints? Well, if it's mainly hyaline cartilage called synchondrosis, it's a cartilaginous joint. If I got fibrocartilage mainly between the 2 bones, it's still a cartilaginous joint. And then if you have a joint capsule surrounding the 2 bones, it's a type of synovial joint. Okay? Now, what type of movement do synovial joints allow?
Dire.
All synovial joints should be freely movable, diarthrosis. For cartilaginous, we're gonna go, the majority will allow for slight movement, and then for all fibers, they should allow for no movement. Hey, mate, why are you back?
I got out of class early.
Okay.
I wanna learn.
All right. So know the joints, you classify them by structure and function. By structure, your choices are fibrous, cartilaginous, snow. Sure you want to sit there?
I usually sit.
Okay. By movement, you have synarthrosis, amphiarthrosis, and diarthrosis. Okay, so I'm going to give you a joint, let's say a hinge joint. By movement, what type of movement should a hinge joint allow? Free movement. Let's say I give you a suture. What type of movement would a suture allow? No movement, synarthrosis. Okay, let's go back to the hinge joint. What type of joint by structure would it be?
Synovial.
Hinge joint, synovial. Let's go to suture. By structure, what type joint would that be? Fibers. Okay, so you want to know how joints are named, structure and function. You want to know the choices of structure. What are the choices for the movement, the function? And then if I give you a joint, tell me what category it would fall under, either by structure, which would be one of these three, and be able to recognize what type of movement, if any, the joint will allow. Now, synovial joints, let's have a look at the picture. There's a capsule, right? There's a membrane here within the capsule called the synovial membrane. We want to know what the fluid, what's the purpose of the fluid called synovial fluid for?
Reduces friction.
One is to reduce friction, but two, it also provides what? Nutrients to the cartilage at the end of the long bone. Okay? Yes, if you want to get away with one, the major thing is to reduce friction.
Yes.
Now, similar to that synovial membrane, you had these little sacs called bursar sacs. What was their function?
To reduce.
To reduce friction. This is to keep things from rubbing on each other, maybe like a tendon or ligament over a bone. Now, similar to that little sac, but wrapped around a tendon, it's called a tendon sheath. And its function, again, is to provide lubrication. Most things at the end in itis tells me that what's occurring?
Inflammation.
Inflammation. So we have inflammation due to overuse and the bursar sacs inflamed. You want to recognize it's called bursitis. If you have overuse of a particular joint and this tendon sheath, not the tendon, but the tendon sheath is inflamed, we're going to refer to that as tendinitis. So know the function of bursar and tendon sheaths. Reduce friction. And itis, if it's bursitis, it would be inflammation of the bursar sac. If tendinitis, it would be inflammation of the tendon sheath. Okay. Now, when a muscle contracts, it provides movement, right?
Yes.
What do we call the attachment site where the bone is moving?
Insertion.
Insertion. When the muscle contracts, what do we call the attachment site where the bone is not moving?
Origin.
Origin. So recognize the difference between insertion and origin. Where's the bone moving? The little phrase to help you remember is to say the insertion will always move toward
The origin.
origin. So let's say the bicep, it's attached to the radius. So you can see my radius is in the forearm, it's moving. And then the origin is on the scapula. So insertion is moving toward the origin. I'll give you another example. Your masseter muscle does chewing, mastication. So what's moving? Mandibles. That would be what?
The origin.
The insertion.
Oh yeah.
And it's moving toward where?
The
The zygomatic bone, which would be the
origin.
origin. So please recognize the attachment site. If the bone moves, that muscle attachment is called insertion. If the bone doesn't move as the muscle contracts, that attachment site is referred to as its origin.
So, will it just wants the name of the bone, or it wants just the name of the bone?
No, we're not going to ask you insertion origins of until like the lab, and we won't ask many. I just need you to know the definition.
Oh, okay.
Now, what are some things to help keep a joint to stay within its attachment site so it doesn't come out?
Muscle tone.
Well, yes, one is muscle tone. Let's just look here though, the shape of the bone. One looks like a ball, it's convex, the other one kind of like a socket. It fits, right? So this would be a synovial joint ball and socket. So the shape of the bones is one thing. What else?
Ligaments.
Tendons and
Ligaments.
ligaments. So let's have a look. Which one's the muscle to bone connection? Tendon. So here you're looking at muscles connected to the bone here and the connections around the joint, right? So these are tendons, and ligaments would be connecting
Bone to bone.
bone to bone. So here you got ligaments, right? Connecting bone to bone around the joint. Now those three, the shape, tendon, or ligament gives the most stability.
The muscle tone.
Well, which is that? Ligament or tendon?
Ligament.
No, so you got
Alright,
wrong.
tendon.
Tendon.
Sorry.
Why the tendon?
Because muscles are always in a state of.
Muscles
A
are always in a
slight
slight state of
of
contraction,
contraction.
so it's pulling on the attachment side, keeping the joint tight. So technically the tendons, due to muscle tone, where the muscle is always in a slight state of contraction, give it the most stability, okay? Now again, tendons and ligaments are avascular or poorly vascular? Poorly. So if I got a slight tear, it'll heal, it'll take a while, but please note, if you tear it,
You're done.
that needs surgery, okay? Compared to cartilage. Cartilage, however, is going to be what? Avascular. There's no vessels in cartilage. Please recognize the fibrocartilage in the knee. The one that absorbs compression is called your
Meniscus.
meniscus. Now, which bone socket joint, which synovial joint? I already gave it away.
Yeah.
Which synovial joint is the most freely movable? Bone socket in the hip or in the shoulder?
Shoulder.
In the hip, it's deeper socket. You don't want it coming out, so you're sacrificing movement for stability. So the one in the shoulder is the most freely movable. It's not the easiest dislocated, but it's the most freely movable, okay? All right, the other thing in this chapter, I'm gonna give you the movement. You tell me the name of the movement by the synovial joint. So let me give you an example. When the muscle contracts, the angle between the two bones is getting smaller. Flexion. The angle between the two bones and the movement occurs, the angle is getting larger.
Extension.
Extension. Pointing my toes upward. Dorsiflexion. Planting your foot to the ground. Plantar flexion. Turning the sole of your foot midline. Inversion. Turning it to the side. Eversion. Throwing your mandible forward. Protraction. Bringing it back in alignment. Retraction. Raising a body part.
Abduction.
Raising.
Raise. Elevation.
Elevation. Lowering a body part or joint
Depression.
depression. So I'm going to give you the definition. You match it to the correct movement, correct chart. Okay? How about this? You're in the anatomical position. Your radius has not crossed the ulna.
Pronation. No. Supination. Supination.
Supination. Using your pivot joint and the radius crosses the ulna.
Pronation.
Pronation. Moving your arm away from midline.
Abduction.
Abduction. Moving a body part like your arm toward midline.
Adduction.
Adduction. Okay. So that's the other thing you'll be asked. Now, did I miss anything in the review? What's tendinitis? Inflammation of
Tendon sheet.
tendon sheet. Bursitis, inflammation of
Bursitis.
bursar sacs. Function of bursar sacs and tendon sheets.
Lubrication.
Lubrication. Synovial joints.
Free movement.
They provide free movement, but you have a joint capsule surrounding the two bones that meet, right?
Yes.
Function of the synovial fluid.
Nutrients and lubrication.
Nutrients to cartilage and providing lubrication between the joint. What's the fiber cartilage and unique called?
Meniscus.
Meniscus. The bone moves, that point of attachment is called insertion. Muscle contracts, that bone don't move, that's the origin. Bones are, how can I say, muscles are attached to bone at least two places, okay? Bend your fingers. Don't give me the finger, just bend it. Flexion or extension?
Flexion.
Flexion. Open them out, extension. What joint's in the thumb to do opposition? Saddle joint. So synovial joint, right? Alright, I think I've got everything. I went over it all. If you find anything, bring it to my attention in lab. I will look over the exam again in lab. But other than that, your lab time is yours. I already gave you the answers to both worksheets, right?
Yes, sir.
Right. We're all good?
Yes, sir.
Alright, let's get out of here so we come